Okay, so let's start with a few problems and work up to more difficult problems. So we're starting with constant force, and remember that constant force is just that. We're not changing anything as we go. So we're going to start with a calculus book being accidentally knocked on the floor, and we want to know how much work is done in lifting the 1.2 kilogram book off the floor to put it on a desk that is 0.7 meters high. Well, the formula that we're going to need to use is work equals force times distance. And we know that distance is 0.7 meters, so that's great. And we know the weight of the book, but since we're working in the metric system, we have to multiply weight, which is 1.2 kilograms, times gravity, which is 9.8 meters per second squared. And that is going to give us a force of 11.76 kilogram time meter per second squared, which, by the way, are newtons. So we can just use the large N or the capital N as newtons. So now we have force in terms of newtons and we have distance in terms of meters. So the work actually that it takes to lift the calculus book off the floor is just the multiplication of the two. 0.7 meters times 11.76 newtons. Since we're multiplying meters times newton, we get the newton meter as our final answer, which is otherwise known as a joule. So 8.232 joules. Okay, another example of constant force. We have dog food kept on the top shelf of the pantry so the dogs can't get to it. So how much work is done in lifting the 20-pound bag of dog food 6 feet off the ground to that top shelf? Well, we're lucky here because we're already in pounds. And as we mentioned before, pounds already include gravity. So when we have work equals force times distance, we can straight up say that the force is in pounds and the distance is in feet. And the units of work in the US customary system are foot-pounds. So we do straight multiplication and we get 120 foot-pounds as the answer to that one. All right, so next question says, if we use a force of 2 newtons, so they're giving us force here, force is 2 newtons, and we moved an object 12 meters. That means distance is 12 meters. And they're asking us to calculate the work. So we just have to multiply. 2 newtons times 12 meters is 24 joules. I promise these problems will get more difficult. All right, so speaking of which, this one's not terrible, but it's definitely more complicated than the last three. So we have an oil spill in a small pond, and we have a thin 0.1 meter layer of oil on top of the circular pond that has a radius of 10 meters. And they're giving us a density of oil of 80 kilograms per meter cubed. The oil must be pumped to a height of 10 meters to remove it. How much work is done to complete the job? The first thing we're going to have to do is we're going to have to calculate the volume of the oil layer. So we're told, well, first of all, we're told it's a circular pond. So, and think about it. We have a circular pond with a 10-meter radius here and then a very thin sliver of it sitting on top of the pond of 0.1. So that 0.1 is effectively the height of the cylinder. And then, of course, this 10 meters is the radius of the cylinder. So the volume of the cylinder is going to be pi times r squared times h. So I have 100 times 0.1 is 10 pi. And in terms of units, I took meters times meters times meters, so meters cubed. Okay, and if you recall, the next thing we had to do was to determine mass, because remember when we're given density, we know that density equals mass divided by volume, which means that mass equals density times volume. So to get mass, we need to take the density that they gave us of 80 kilograms per meters cubed and multiply it by 10 pi meters cubed. So mass equals density times volume, and these meters cubed cancel out, and I'm going to be left with 800 pi kilograms. All right, well, we now have mass, but we still need to get force. And remember that force, when we're in the metric system, is going to be mass times gravity. So we have 800 pi kilograms times 9.8 meters per second squared. And those units that we'll end up in will be newtons. So we have 800 pi times 9.8, which is going to give us, I'm getting, let's see, 7,840 pi. And remember that kilograms times meters divided by seconds squared are in newtons. Okay, so now I finally got myself all the way to force. I know that I had to move this oil 10 meters. So remember that work equals force times distance. So I'm going to have 7,840 pi newtons times 10 meters, which is going to give me 78,400 pi joules.